All right, so in 10-4, we're going to be working with triangles, rhombus, and trapezoids. So you got 3 of them this time instead of just 1. And here are your formulas. Here's your formula you all should know for your triangle. Your triangle formula is what it is because it's derived from, as I told you the other day, the formula for a rectangle or a parallelogram, depending upon how the picture is drawn. I'm going to sneeze. So if I were to tessellate this triangle, it'd be something like that, wouldn't it? Right? So the formula for this whole outside figure is a parallelogram. Base times height, but I only want half of it, so that's why we take half base times height. When you look at the trapezoid formula is a little bit more complicated, but if I tessellate the trapezoid and flip it and slide it, it tessellates also into a parallelogram. This base 1 would be down here because I would flip it and then slide it over, and this base 2 would be up here. So the entire base for the outside parallelogram is B1 plus B2, isn't it? So isn't this the total base of the outside parallelogram? And then still times the height, so here's your H. But again, just like the triangle, I only want half of it. So we have half the sum of the bases times the height. And then we come to, and both of these are on your Ames reference sheet. This one, however, your rhombus, is not. Your rhombus formula you need to memorize. We need to find the diagonals of that rhombus. And what do you know about the diagonals of the rhombus, by the way? How do they meet? How do they intersect? They do bisect each other, but they also, they're perpendicular, right? So don't forget that. That's going to be important. You could end up creating 45, 45, 90 triangles, 30, 60, 90 triangles in here, and have to use your special right triangles also. But you need to memorize this. Then on top of that, if I were you, I would add the following additional formula that is not in your book, but it will help you tremendously. I would look at, let's go ahead and put it up here. What kind of a triangle is that? So this is an equilateral. Your equilateral triangle. So I know that you already have a triangle formula of 1/2 base times height. However, as you're going to find out later, they don't always give you the height of that equilateral triangle. And we can find it, but you're going to see that there's a harder way that you could do this versus an easier way. So I'm going to go ahead and give you the following formula. And I would study it if I were you. So S squared, meaning side. So the side lengths, this is S, and this is S. S squared times the square root of 3 all over 4. I will show you how it's derived later, but it's essentially derived from your 30, 60, 90 triangle. Remember, if you take an altitude from one of the vertices straight down to the other side, it cuts this in half, and you end up with a 30, 60, 90 triangle. And across from 60 degrees, isn't there rad 3? True or false? Across from 60 is rad 3, right? That's where this rad 3 comes from. And then these come from your half of your base times your height. Isn't this half of the side S right here? So 1/2 of S, so there's part of that 2 out of the 4. But as I said, when we get to a further section, I'll show you how that's derived. But I'm not going to take the time to do it today. But that's where it comes from. All right, so then we're going to look at some problems. Here's some very simple ones. Name that figure and then write its formula. What formula are you going to write for this one? Yeah, so I want to see the general formula, 1/2 B times H. And then you're going to plug in to that general formula before you use your calculator. And so you've got 1/2, use your units of measure. So my base is 80, is that 26? Yeah, 26. 26 inches, and my height is 19 inches. And then you can use your handy dandy calculator. For 1/2, you can put a 0.5. If I were you, that's what I would put in. And then times 26 times 19. So I get 247 what? So 247 inches squared. Do not skip this part. If you skip that part, I'm going to start marking you wrong. Get in that habit. Because we're going to get into some tougher stuff with volume and surface area, and you've got to be in that habit of writing those formulas. Alright, so this is your trapezoid. We've got our bases and our height, which is all we need. So we're going to start out with 1/2, or A equals 1/2. I like doing the sum of the bases times the height, but that's just me. You can put it in whatever order you want to. So plug in what you need to. Using units of measure. So we've got 20 millimeters, 24 millimeters, those are your bases. Your height is 8 millimeters. When you add millimeters together, they just become plain millimeters. So I end up having 1/2 times 44 millimeters, bless you, times 8 millimeters equals. And then you can put the rest in your calc if you want. So 0.5 times 44 times 8. 176 millimeters squared. Then we come to the rhombus, and they're giving us the diagonals in the rhombus, and area equals 1/2 diagonal 1 times diagonal 2. The whole length of that diagonal. Now they've split the diagonal to try to confuse you. I'm going to take that whole length. So this is 20 meters, and this whole length is 24 meters. So 1/2 of 20 is 10, 10 times 24, the area is 240 meters squared. So then we come to some harder problems. So those are just straightforward ones. And then look at number 4. So number 4, what kind of figure is that? I don't know that it's a square because I don't see any right angles in there. So that's a rhombus, okay? And they've given you one of the diagonals in the rhombus, and they've given you one of the side lengths, correct? I need both diagonals. So if I run a diagonal through here, first of all, isn't this split because it's bisected into 6 and 6? And so then I'm going to call this one X and X. I know that I have a right angle here. How can I find that missing part of the diagonal right here? Knowing that this is 10 and this is 6 and it's a right triangle. Pythagorean's theorem. Yep. So we're going to do step number 1. I'm going to take, my hypotenuse is 10, so I'm going to take 6 squared plus x squared equals 10 squared. So 36 plus x squared equals 100. Subtract 36. I get x squared equals 64. Square root of x squared and 64. Don't I get 8? So that means that this is 8 and this is 8. So now I have everything that I need to run it through my formula. So step 2, area equals 1/2 d1 times d2. You got to memorize that formula. Plug and chug. 1/2 times, what's my distance of this diameter, or this diagonal? Sorry. 12 meters, right? And this one? 16 meters. So handy dandy calculator. .5 times 12 times 16. So I end up with 96 meters squared. Then this one is a blast from your past. It's a trapezoid. What does that 24 represent? Isn't that the median of that trapezoid, and isn't this an isosceles trapezoid? Do you remember the formula for the median of a trapezoid? The median equals, say it again. Okay, so if we're going to call this, we'll just call this one base 1 and we'll call this one base 2. And so Ethan just said 1/2 base 1 plus base 2. Oh, isn't that part of our trapezoid formula? And that's what the 24 equals. And so this equals 24 meters. Can't I just replace that entire part of the formula, 1/2 the sum of the bases, with 24? And then all I have to do is find the height. Have they given me the height? Isn't that the height right there of the trapezoid? Sometimes they'll give it to you on the outside to confuse you. So this is the height of the trapezoid. And so area equals 1/2 sum of the bases times the height. I'm going to replace all of this here with 24. All of that. So I get I get 24 meters times the height of 9 meters. 9 times 4 is 36. And 9 times 2 is 18, plus the 3, 21 meters squared. So don't stress that you don't know what B sub 1 is or B sub 2 is. Notice that, oh, that belongs to part of that formula. Then we come to this. What thing is that? Yeah, so equilateral triangle, if I hadn't given you the formula, this is what you would have to do. You'd have to bring this height straight down, and that's what we would need because we got the base. But I would know that this is a 60-degree angle there, and I would know that if that's 10, this is 10 centimeters here, or this is 5 centimeters here because this is bisected. So you could either use Pythagorean's theorem to find the height, or you could use your 30, 60, 90 information. So you'd have to go through all of that work. Wouldn't it just be easier to use the formula that I gave you? I mean, you can go through that work if you want to, and that's fine. But I would rather use A equals S squared radical 3 all over 4. My side is the only thing that I have to plug in for. And my side is 10 centimeters. So don't I end up with, I'm going to go backwards on this one because I'm running out of room. 10 centimeters squared is 100 centimeters squared times rad 3 all over 4. What happens with a 4? It divides into 100 how many times? 25. So my final answer is 25 radical 3, and then the meters squared does go on the end. That was a lot less work though, wasn't it? Than what we could have had, might have had to do. All right, then let's look at 7 and 8. So 7, 4-step plan. It's a word problem. It says the area of a triangle is 150 square inches. If the height is 20 inches, find the length of the base. So I've got a triangle. I don't know what kind of triangle it is, so I'm just going to draw any triangle. And they had told me that the area is equal to 150 squared inches. And they also told me that the height is 20 inches. We need to know the base. What major tool have they given you? What major tool have they given you? The area of a triangle. So immediately you are going to write that formula, because that's your blueprint. That's how you're going to set up your equation to solve, and you're going to plug in for what you know. I know the area is 150 inches squared equals 1/2 base. My height is 20 inches. So how are we going to solve? You could do one of two steps first. What do you want to do first? Do you want to deal with 1/2 first? Could I take half of 20? If you can take half of whatever this number is here, then do it. If this is an odd number, then I would multiply this side by 2 to get rid of the half, and multiply that side by 2. So since I can take half of 20, I would actually rewrite it as 150 inches squared equals half of 20 is 10 inches times b. Now don't I divide by 10 inches? And I don't even need a calculator, right? My zeros cancel, I end up, and this inch cancels with one of those, so I end up with 15 inches equals my base. Has that answered my question? Yes. So therefore, the length of the base is 15 inches. Last question. Question number 8, a rhombus. So I'm going to draw a rhombus. Give or take. Has a perimeter, oh that's different, has a perimeter of 100 meters and a diagonal 30 meters long. Don't worry whether you put the diagonal in the right place or not. I mean, there's a long diagonal and a short diagonal oftentimes. And I know that those are right angles. So if one of the diagonals is 30 meters long, doesn't that mean that this would be 15 meters and this would be 15 meters? I like to split them up for a reason. We have to find the area. What do I need to find the area of rhombus? Both diagonals. So I have one. How am I going to get this diagonal here? And why did they give me perimeter? What are you going to do with that perimeter? They had to have given it to you for a reason. Yeah, so you can find the outside. Remember from that this question over here that we did? We had the outside there, and then we had one of the diagonals. So we can just follow the same route where we do Pythagorean's theorem and apply the formula so long as we have or we know what that outside length is. How many sides are there to a rhombus? 4. So my very first step is to take perimeter of a rhombus would be 4 times s, or 4 times the side, right? I know that my perimeter is 100 meters equals 4s. So divide by 4. Doesn't each side length equal 10 meters? So now I know that this is 10. All 4 of them are 10. Oh, sorry, thanks. What was that? Was that you, Tony? It was, wasn't it? No. All right, so you're right, 25. I was just seeing if you're on your toes. So 25 meters. Now what do I do? Pythagorean's theorem. So step 2. Now I have, remember, this is your right angle, so 25 is across from my 90, so it's my hypotenuse. So I have 15 squared plus, oh, we'll call that x squared equals 25 squared. So 225 plus x squared equals, remember what 25 squared is? 625. And 625 minus 225 is equal to 400. So what's x? 20 meters. And that's just half of the diagonal, right? So that means that this is 20 meters, so this is 20 meters. That's a pretty big rhombus. So now third step, I'm going to squeeze it in here, area equals 1/2 d1 d2. So 1/2, what's my whole diagonal here? 30 and 40, right? So 30 meters and 40 meters. I'd rather than, instead of taking half of one of these, I'd rather do 30 times 40 is what? 1,200, right? What's half of 1,200? 600. So isn't my area, turn it to the side, 600 meters squared? Therefore, the area of the rhombus is 600 meters squared. Okay. So your homework, again, has two parts to it, practice and text